This is a May, June 2023 variant for 2. Question number 3 carries 2 marks. You have to state the first law of thermodynamics, and then after that, identify the meaning of any symbols that you use. The change in internal energy, delta U, is equal to the work done, W, plus the energy transferred by heating, Q. That means your delta U equals to W plus Q. Then the increase in internal energy is equal to the work done on the system plus the heat energy transferred to the system. You need to know when your W is positive or negative, when your Q is plus or minus. And then, therefore, you know delta U is either increase or decrease. Then for part D, the state of an ideal gas is continuously changed according to the cycle A, B, C, D, and then back to A, as shown in the figure 3.1. Complete table 3.1 for the changes A to B and B to C by placing 2 ticks in each row. To do this question, you need to know that the internal energy of an ideal gas is only due to the random distribution of kinetic energy. The potential energy is 0. So from A to B, the gas contracts at constant pressure. This means that the work is done on the gas to compress the gas. That means your W is positive. This is why you tick here, 1 mark. This question carries 4 marks. This is 1 mark. And then for the pressure to remain constant, at the volume decrease and the pressure remain constant, means the molecule must move slower. As you can see from the arrow here, which is longer, this arrow is shorter. That means the molecule moves slower. The kinetic energy decreases. And because the kinetic energy decreases, the temperature decreases. And then the internal energy also decreasing. This is why you put a tick here. The change in internal energy decrease. This is what happened from A to B. From B to C, the pressure of the gas increases and the volume stays constant. This means that no work is done on or by the gas because delta V is 0 from B to C. The molecule has to move faster as indicated by the longer arrow here, move faster to create an increase in pressure. So your kinetic energy increases and therefore your internal energy also increases. This is why no work is done from B to C because delta V is 0 and then the internal energy increases. In part 3, we have to use the first law of thermodynamics to describe and explain the energy transfer associated with one complete cycle A, B, C, D, A. For one complete cycle, the overall change in internal energy is 0. This is because the gas is at the same temperature when it returns to A. Then the second point, this question carries 3 marks. The second mark comes from more work is done by the gas in CD than is done on the gas in AB. Means the work done on the gas in AB is numerically less than the work done by the gas from C to D. From C to D, work is done by the gas because the gas expands. From A to B, work is done on the gas because the gas contracts. Work done on gas in AB because gas is compressed. Work done equals to positive P times delta V. Work done by gas in CD because the gas expands. More work is done because P is larger. The pressure here in CD is larger than the pressure in AB. Therefore, this value is numerically larger than this value here. Or we can also say that no work is done from CD, CB, and AD. No work is done on gas in BC and DA. This is because there's no change in volume. The change in volume here is 0. So this will carry 2 marks. So therefore, there must be an overall input of internal energy, because if we look at the first law of thermodynamics, delta U equals to Q plus W, your W is negative. Since your W is negative, your Q must be positive in order for delta U to be 0. this value is negative, so your Q must be positive. It means energy must be put into the system in order for the change in internal energy to be zero. And then this is a summary of the facts that you must know to solve this question. You must understand internal energy that a rise in temperature of an object is due to an increase in internal energy of the object. Number 2, you must be able to recall and use PW work done equals to P times delta V, where delta V represents the change in volume, and understand the difference between work done on a gas and work done by a gas. Then number 3, work done by a gas and work done on a gas. And then number 3, must be able to recall and use the first law of thermodynamics, delta U equals to Q plus W, and know when your U, your W, and your Q are positive or negative.